Good day, everyone. My project is Carbon Footprint Tracker, a green software engineering approach. It's a mobile-first web application designed for sustainable commuting in Penang. The system helps users record daily commuting activities, calculate carbon emissions and calorie expenditure, weekly meetings statistics, and maintain low carbon habits through gamification, fund companies' weekly reports and notifications. Daily commuting is part of everyday urban life. Every trip by car, motorcycle, bus, or cycling creates a different environmental impact. However, this impact is usually invisible to ordinary commuters. People may know that low carbon travel is important, but they often do not know how much carbon their daily transport choices generate. This creates a practical problem. Commuting happens every day, but carbon awareness does not happen automatically. Without a simple tracking tool, users may continue their usual travel habits without understanding the environmental difference between different transport modes. This is the starting point of my project. In Penang, daily commuting still relies heavily on private cars and motorcycles. This makes transport-related emissions a relevant local sustainability issue, especially under SDG 13, climate action. At the same time, many exciting carbon platforms are designed for corporate ESG reporting or broad lifestyle audits. Their tools may be useful for organizations, but they are usually too complex for ordinary commuters who only want to track daily travel. Therefore, this project focuses on a simple, lookless, and mobile-first carbon tracking tool for daily commuting. Sustainable commuting is not only about telling users to reduce emissions. For a system to support real behavior change, it must make daily tracking easy, meaningful, and practical for repeat use. This is why the project focuses on low-friction interaction and repeat feedback. A commuter-focused system should not require users to complete a long form every time they travel. It should help users record routine trips quickly, understand the result immediately, and return to the system regularly. This leads to main gaps addressed in this project. This project addressed three main gaps in existing carbon tracking tools. First, many tools require a high input burden. Users may need to guess distance, repeat travel details, or complete multi-step forms. This factor point discount regular use. Second, many tools are not designed for daily commuters. They focus more on corporate ESG reporting or body lifestyle orders rather than individual commuting behaviors. Third, many systems have weak local and behavioral engagement. Generic dashboards may not reflect Penang community habits or motivate repeat use. Therefore, the challenge is not only carbon calculation. The challenge is to build an accessible and engaging system that helps local commuters record trips, interpret their impact, and maintain sustainable commuting habits. The project has four main objectives. The first objective is to track daily commuting emissions. The second objective is to provide carbon safety and calorie feedbacks, so users can understand both environmental impact and health-related benefits. The third is visualize commuting patterns and user progress through dashboards and summaries. The fourth is to encourage sustainable commuting behavior through gamification, friends, and weekly feedback. The target users are Penang commuters, university students, university staff, and office work who want to practical tool for understanding and improve their community impact. The solution is Carbon Footprint Tracker, a localized mobile web application for sustainable commuting. The system directly responds to identify gaps. To reduce input burden, it provides person-to-Penang routes and custom route confirmation. To improve personal carbon feedback, it calculates carbon emissions, carbon safety, caloric feedback, and displays the results through dashboard. To support long-term motivation, the system includes gamification, weekly green score, weekly reports, and notifications. In addition, the project applies sustainability-aware software design through length-week calculation, local caching, schedule aggression, and reduce unnecessary processing. The system is divided into 7 main modules. The user management module supports registration, login, authentication, and profile management. The commute record model allows the user to record trips using precise routes or custom routes and view their commit history. The carbon calculator model calculations carbon emission, carbon safety, calories, and points. The analytics models present trend model distribution and sustainability summarize. The gamification model supports badges, labels, experience points, and challenges. The social and leaderboard model supports friend requests, friend lists, and weekly ranking. Finally, the weekly report and notification model generates weekly reports, feedback, and in-app notifications. Together, these models form an integrated full-stack system, not just a simple carbon calculator. The system follows a three-tier mobile web architecture. The presentation layer is implement user React, TypeScript, and Wait. It includes the main pages such as home, record, status, friends, and profile. The application layer is implemented using Node.js and Express. Express provides REST APIs for authentications, records, friends, reports, notifications, and maps. Authentication is used to protect user-specific data and provide models. The data layer uses MongoDB as a primary database. It stores users' computer records and notifications. Local storage and ArcGIS are used as supporting storage for caching, recovery, and browser-side supports. The system also uses backend map proxy for route confirmation and a schedule backend process for weekly report generation. This architecture supports modular data consistency and green software engineering principles. Now I will demonstrate the complete workflow of system. First, you will need to log in with a valid email. And a password with at least 6 characters. After a user ticks, the system redirects the user to home dashboard. The home dashboard provides a quickly summary of the user commuting performance. It shows today's carbon data, calories, burdens, current commutes, and compares with last week. The health score section summarizes the user environmental health, economic, and social performance. The system provides a smart recommendation, such as encourage continue recording your comments. And this is recent budget. Next, I will demonstrate the record page. This page provides two recording modes, preset routes and custom routes. First, I will use the preset route mode. For example, I select Georgetown to Butterworth. Then select transport mode. The system supports different transport modes such as car, motorcycle, bus, walking, and so on. If I choose car, the system automatically takes the carbon emission. Then the user clicks Submit Record to save. The second mode is custom route recording. In this mode, user enter start point and end point. For example, I enter Penang Airport and USM. The system automatically calculates the route distance. Then, if I use walking, the system can also estimate the calorie. Then the user submits the records. Now I will show the statistics. This page converts commute records into visual insights. User can view carbon saved, total distance, total trips, current commute percentage, and the comparison with the last month. The system also allows user to set goals. User can enter goal title, and choose goal type and target value in the data to save goal. This function helps motivate the user to keep using the system over time. The statistics page also includes transport distribution and the commute time heat map. The transport distribution chart helps users understand whether they rely more on private vehicles or green transport mode. The heat map shows when users usually record commute during the week, providing more detailed behavior insights. And the advanced charts section provides deeply analysis. The trend prediction chart can show daily, weekly, or monthly, including actually consumed person, carbon saved, and trip count. The multi-dimension benefits chart summarizes the user environmental, health, economic, and social performance. This makes the feedback more comprehensive and easier to understand. The system also includes achievement and budget. User can unlock the budget such as first commutes and commute beginner. Lock the budget so progress requires. This gamification designed to encourage users to keep recording and building low-carbon commuting habits. The friend model supports social interaction. Users can view, connect friends, pending, and requests. They also search for users' net name, user ID, and keywords. User can also view leaderboard with friends. Finally, the profile page summarizes the user's personal information, level, experience, and progress. User can also switch the language between English and Chinese, and enable or disable notification weekly reports. The weekly report and notification functions correct and automate the feedback loop. Users do not only record the trip, they also receive weekly suggestions. This completes the system demonstration. The workflow shows that the system integrates authentication, commute recording, gamification, funds, weekly reports, and notification, and so on. Compared with the typical carbon tracking tools, this system has 5 main differences. First, it applies a green software engineering approach. The system uses lightweight deterministic calculation, local casing, schedule algorithm, and avoid unnecessary heavily process. Secondly, it is supposed to model commuting logging. User can select a precise peanut route or customer route. Third, it uses a dual metric calculation engine. The system calculates the carbon emission, carbon saving, and calorie expenditure. First, it introduces gamification behavior, reinforces budget, weekly goals, and weekly risk. Fifth, it provides automated weekly feedback through weekly reports and in-app notifications. From an entrepreneurship perspective, this system can be extended beyond an individual carbon track into an institutional sustainability engagement platform. The target customer can include universities, sustainability office, student affairs departments, student communities, and organizations that want to promote low carbon commuting. Product value is that institutions can use the system to run green commuting campaigns, motivation students or staff through badges and leaderboards and generate carbon-aware reports. A possible revenue model is an institutional subscription model combined with campaign customization packages. For example, a university could run a semester long green commuting campaign with customer badges, leaderboard rules, reward activities, and summarize reports. In the future, the system can be expanded with a campus-wide dashboard, reward partnership, public transport integration, and ESG reporting support. For field work, the system can be extended with a campus-wide automated dashboard, public transport integration, improved map policy releases, enhanced weekly report visualization, AI-based green road recognition, and reward partnerships with university events. The primary SDG element of this project is SDG 13, climate action. Because the system helps users understand, track, and reduce community-related carbon emissions. It's also related to SDG 11, sustainable commit and commutes, by supporting more sustainable commuting behavior, and SDG 12, responsible consumption and production, by encouraging more responsible transport choice. In conclusion, carbon footprint tracker applies software engineering practice is to create a practical, working, and extensible system for sustainable commuting in Vietnam. The system combines commuter recording, carbon and calorie calculation, dashboard visualization, gamification, friendly weekly reports, and notification into one integrated mobile web system. Overall, this project demonstrates how low-cost commuting analytics and sustainable software design can be combined into a practical carbon tracking platform. Thank you for watching my presentation.